So 1 we'll walk through together, a little refresher. 2, I'll give you 3-4 minutes to knock out number 2. Make sure you can do it on your own. And then definitely 3 and 4 we want to make sure we get to. Yeah, Alexis, question? You're kind of freezing in and out right now. All right, Alexis, I hate to break it to you, but you're frozen. So if you're talking, I can't hear you right now. So I'll let you know when I see you again. If you have a question, I'll call on you, okay? Or I'll call you when I see you. You can ask your question. All right, so number 1, it says the graph of the function. So here's your function. I want you to graph that showing at least 2 points on each side of the vertex. So we'll talk about what that means here in a minute. And then you're going to describe the transformations that from the original graph. So if we look at our original graph, my computer's not working. There we go. What did we do to this in this equation that would change the original? So in this problem, we really do all 4 things that we've talked about. We definitely move it left, right, up, and down. All right, Alexis, you're back. So while you're live, did you have a question?
Yeah, can you hear me?
I can hear you, yep.
Okay, it wasn't letting me unmute, but what page is this on again?
It's page 14 in the packet that says the tasks on the front.
Okay, thank you.
Yep. Okay, so the first thing, we just go in order. So let me erase all of this, and we can kind of just go right in order. The fact that we have this little negative sign, what that tells us is that this thing has been reflected. You could also just say it opens downwards. I would take that. So that's what the negative gives us. As we continue moving left to right, you see this 1/2. Anything between 0 and 1, so smaller than 1, that's going to make our parabola, and then I mentioned this the last period, that's going to make our parabola wider. So if I just simply ask you what happens with the parabola and you use the word wider, that's totally fine. Just know if it's like a multiple choice question tomorrow, there's a reasonable chance I'm going to use, the official math vocabulary, and then that would mean that we would say it's compressed. So just know that compressed means wider, in case I use that word tomorrow. We continue along here. If I have this x minus a2, that tells us that this shifted right 2 units. And then the last thing, if we tack on a +4, that tells us we're going to go up 4. That hopefully we have a pretty good handle on, I think. The one thing I would just be careful of tomorrow is knowing if we're wider or narrower. Okay, and then knowing what the math words are, stretched or compressed. I think everything else will probably be pretty good with. The vertex then. This we're consistently answering better. Since this is an x minus a2, that means our x coordinate of the vertex is a +2. We can also just look at the fact that we moved to the right, would have gone from 0 to a +2 direction if we went right. And then 4 is the y coordinate. The axis of symmetry is that line that cuts our parabola directly in half. Tomorrow, make sure if I ask you for the axis of symmetry, which I do, that question I do know I wrote, and you have to fill this in. Don't just give me the numerical value. Make sure you actually say this is a vertical line by saying that it's x equals. So if you don't have that, that's going to be a really bad way to lose a point. So make sure you're writing that as x equals. And then it has to be, it goes right through the vertex, right? It always goes through the vertex. So the x coordinate that it would have to be going through would be the x coordinate of your vertex. So it would have to be x equals 2. Now, let's go ahead and graph, and then we'll talk about the maximum and the minimum, even though we could probably do that without, but we're going to graph this now. So what I want you to do is graph this parabola. I want you to show at least 2 points on each side of the vertex. So here's what that references. First, we can graph the vertex without a problem. So here's our vertex. Go ahead and plot that point. All right, so the point 24 is our vertex. I don't give you a table, but setting up your information in table format is a good idea. So if you wanted to set up your little table, the way we've been doing this, we have x, and then we've talked about how, maybe it's a little smaller, the vertex is the point that I would put in the middle. So this. So the point 2, 4 is the one that I would put right here. So when I'm referencing giving me at least 2 points on either side, it's similar to what we've been doing where I pick like 3 and 4. And then once I know what 3 and 4 are, that would also tell me the 2 points directly in front of it as well. So now we need to plug those in, figure out what all those are. I didn't leave myself a lot of room here. Okay, look. So we took our equation, y equals this negative 1/2. I'm going to erase this so I have some room. Since our x-coordinate was at 2, we would want to use the x value of 3. That's the point right next to our vertex. So we're going to let x be a 3. And then we just go through evaluating this. So 3 minus a 2 would be 1. We would then do 1 squared, which is just a 1. We then ultimately get a negative 1/2 plus a 4, which should be 3.5. So if you set up your table, I erased it so I had a little room to work, but when x was 3, we got a y coordinate of 3.5. So we then plot that point. So go to the x value of 3, 1, 2, 3, and then now 3.5 should be right in the middle of the 3 and the 4. Before we do anything else in terms of getting our values, I'm going to draw in the axis of symmetry. So sketch that in real quick. And then we can immediately plot the point on the opposite side. So what I mean by that is take this point here. The whole idea of this axis of symmetry is cutting our parabola in half. So if I have a point right here that's 1 unit away from the axis of symmetry, if I just go to 1 on the opposite side in that same direction, 1 unit away, I immediately can graph a second point. So by knowing this one, I'm also going to know that one. It's the same thing setting up our table. If you had your table, you would just go to the point before and we would give it the exact same y value, okay? From there, I'm going to plot 4. So let's go here. Uh-oh. So we currently did 2 as our vertex, 3. So now I'm going to figure out what's happening over here at 4. So that's the next point I'm plugging in. So let x be a 4. The 4 take away 2 is 2. The 2 squared is 4. Half of 4 is 2. So half of 4 is 2. But since we have it, one of them being negative, that should be a negative 2 plus a 4. So we would get a y value of 2. So when we plug in the x value of 4, we got a y value of 2. That's the next point that you're plotting. So we go over here to 4, 2. Notice this new point here is 1, 2 units away from the axis of symmetry. So if I just go 1, 2 units away on the other side of the axis of symmetry, I can immediately plot that other point. That's what I now mean by at least 2 points on each side. Each side is the axis of symmetry, or that's the middle anyway, so now we want 2 points on the left, 2 points on the right, and then we'd satisfy what I'm looking for. So from here, we can now connect this. We said earlier that the parabola opens downwards. That plays out with our graph. Now we should be able to look to determine, do we have a maximum or do we have a minimum? So if we look at our parabola, the vertex is always your maximum or your minimum. It's one or the other. It's either the highest point or the lowest point. So for this one, here's our vertex. Pretty clearly, that's our highest point. So what that means is we have a maximum. We don't have a minimum here. We just have a maximum. The maximum, we haven't done this in a week or so. We always talk about how it's got to be the y value. our y value has to be the highest point on the parabola, which is the y value of 4. Okay, that's what this y value is. It's also just the y coordinate of your vertex. So that's a 4 here. And then domain and range. This would go left and right forever. That one I think people get pretty nicely. And then the range is the smallest y value to the biggest y value. So notice how this goes down forever. So it doesn't necessarily have an actual smallest value. What that then tells us is our range starts at a negative infinity. It just gets smaller and smaller and smaller and smaller. But the largest y value is the maximum y value of 4, and we would want to throw a bracket around that one. Okay. Any questions on any of that? So what we've been doing for the last week or so, it's been interrupted with the weekend and then obviously a day off yesterday, but definitely what we're going to be quizzing on tomorrow. So we good? All right, then what I'm going to have you do, because 2 is very, very similar, give you 3 or 4 minutes and just go through all of this stuff and make sure that we can get all this stuff down. So we list your transformations, identify the vertex, answer all these, and see if we can graph it. All right, so take a few minutes and see if we can get all this. And we'll come back together here in a little bit. All right, give you another minute here, and then we'll see how we did. All right, let's see where we're at here. Let's go around, see if we can fill all this in. I'm gonna go Paige first, although she might be frozen. Can you hear me, Paige? Now that I look at you, you might be frozen.
Yeah.
Okay, so give me one of the things you wrote down up here for the transformations. Good. So we're gonna get shifted left 1. So we can see that here, this positive 1 is telling us we're gonna get shifted left 1 unit. Good. Hala, what do you got for a second thing?
Down 3.
Good. The -3 right here at the end tells us that this got shifted down 3. And then Victoria, go ahead. What do you get for the third thing?
Stretched.
Good. This parabola also got stretched. How do we know that, Victoria? How did we know that? What did you see?
The number in the beginning is 2, so it would be it's greater than 1, I think.
Good.
So
Perfect. So that 2 that's in front of everything is greater than a 1. That tells us that our parabola got stretched. That means it's going to be narrower. So when we graph this, it should be a narrower parabola. All right. Jacob, what do you think for our vertex? Jacob M.
-1, -3.
Good. Perfect. -1, -3 is our vertex. We went left 1, down 3, or we can look up here. This would also, we can just look at that and get our vertex. If I ask you the axis of symmetry, Cameron, what do you think?
x equals -1.
Good. It's got to cut right through the vertex, so we don't even have to look at the graph to do this. The axis of symmetry will go right through the middle of the parabola. The vertex is the middle of the parabola, and the x-coordinate in that point is the -1. So the axis of symmetry would have to be x equals the -1. That's our vertical line. Good. All right, if I ask you if we have a maximum or minimum, Thalia, what do you think? A maximum or a minimum?
I said that the maximum was -3.
Um,
Was -3, and then there was no max. I read that wrong. Sorry.
Good. So we have a minimum here. And then you said it was the y value of what?
-3.
Good. So we have a y value of a -3. Notice we don't have our graph yet. We'll graph it in a minute. We'll confirm this. But as long as we know this parabola is opening upwards, then the vertex has to be a low point on our graph. That's why that's a minimum. She said we ultimately don't have a max because a parabola that opens upward is just going to be getting larger and larger and larger. Okay, good. The domain, I kind of sketched it out over here a little bit. So if I ask you for your domain, Natalie, what do you think for our domain?
Infinity, infinity.
All right, so -infinity to infinity. We go left forever and then right forever. I'll wait on the range. I do think as a general practice, you probably want to look at your graph to identify the range if possible. So we'll go ahead and graph this real quick. So you would have graphed -1, -3. And then what I'm going to do, let me draw the axis of symmetry in right away. Because if I can now get a point directly on the right, all I got to do is flip that around that line and I get another point on the left. So we would take this equation, or if you have your calculator, know how to use that, and this will fill in your table for you. It makes this nice. But what I'm going to pick is, if this is the x value of -1, I'm going to pick the x value of 0, and I'm going to plug that in. 0 plus 1 is going to be a 1. We then square our 1. 1 squared is just 1. We do 2 times a 1 to get us a 2, and then 2 minus 3 should be a -1. So what that means, when x was 0 here, we get a y value of a -1. So go to your graph. Right here at 0, -1, you're going to plot a point. That also now allows us just go to the other side of that line and just flip this point around that other side. That tells us we would also have a point right here. Okay, good. We need one more point. I said I wanted, that's your directions here, at least 2 points on each side. So we currently got 1. So we want one more. So I would just keep moving over. The next x value is the x value of 1. So we'll plug in the 1. That. And then this will give us our y value over there. So we'll get 2 squared. Don't ask me where that 4 came from. 3. And then just continue solving. This would be 2 times 4 minus 3. 2 times 4 will give us an 8. So what we would end up with is 5. So if you graph this correctly, you would also have a point up here at 1, 5. Notice how that's 2 steps away from this. So if we just do a reflection, 1, 2 on the left, we then have 2 points on both sides. We can now draw this in, and hopefully that's what you drew. All right. All those things to some capacity tomorrow you're going to need to be able to do. Although, let's do our range now. Now our range, our minimum value here, I think Thalia gave us this, was the -3. That's the smallest y value that we would have hit. And then clearly we're going up forever. So our range is a -3 with a bracket to infinity with our parentheses. All right, we feeling good about this? Hopefully got most of that. Okay, good. All right, so now the new stuff from Tuesday. So these are what we were doing on Tuesday. You had to do this a little bit in your homework. Here's a graph, kind of the exact opposite now. In the problems we just got done doing, you're given the equation, you're making the graph. Now you're given the graph, you've got to come up with the equation. So what we talked about with these, in general, the part that's going to take a little bit of work, we're going to have to figure out what that A is. But by just looking at our graph, we should be able to figure out what's going to go right here and going to get added or subtracted at the end. So do those 2 things real quick. Fill out what's going to go in the parentheses with x and what are we going to be adding or subtracting behind the parentheses. All right. What we talked about when we did these is finding the vertex was the key to these, making sure we can identify that. And on a parabola, you just look at your highest or lowest point. So this is our vertex. You can see the x coordinate is a -5 in that vertex. And then the y coordinate in that point is this -6. By knowing that, we should now be able to come up here where I have these yellow little blobs. We should be able to fill that in. All right. So, Christian, what do you think? Inside the parentheses, what would we have? X, and then what if this is our vertex?
+5.
Good. So this will become x plus a 5, and then on the back side, we're going to have what?
-6.
Good. So that gets us started. Just knowing the vertex allows us to plug that in and be all set. What we now need to do to figure out your A, so I'm going to rewrite this underneath what we know. So now we need to figure out what A is. Notice how all these points are marked for you. You have this point, this point, this point, and this point. So we have 4 options to choose from, where our graph goes through nice corners where we know nice integer values for the x and the y. So we can now pick any of these 4 points. It doesn't matter which point we pick. They're all going to give us the exact same value for A if we do the work correctly. All right. So, Yusuf, what point do you want to pick, Yusuf? 1, 2, 3, or 4 that I have labeled in red?
4.
All right, so Yusuf's going to pick point 4 up here, and I'm going to erase the number 4, and we're going to identify what those coordinates are. My eraser will work. So we're going to be using, since we're using that point, the coordinates 1, 3. So then we just come over here where we have the y coordinate. The y coordinate of that point is a 3. So we're going to substitute 3 in for that y value. When we come across this x variable, we're going to get rid of this x variable with the x value in our point of 1. Once we've substituted in that point, or if you wanted to just experiment and try one of the other 3 points that Yusuf did not pick, we should still get the exact same answer. Now all we're left with is this a. So now we just go through solving the equation for a. So you're going to get a and then 6 squared. Six squared is 36, and then times that a, and then take away our 6. Now we just have an equation, so add 6 to both sides. Space here. So plus 6 plus 6. Pretend that's a 6. So that's going to cancel. We get 9 equals 36a. Divide both sides by 36. We'll want to reduce this, but 9 divided by 36 should reduce down to be 1/4. Okay? So then what that allows us to do, we can now go back up here where we had this a, and we now know that that is 1/4. Okay? All right, real quick. I see some of you looking at the screen still, so I don't want to move this. If you're done, real quick, go to number 4. Identify your vertex in number 4 by the table, and then see if you can get that started real quick so that when I do start it, we can at least get the right answer and see if you can get it, okay? But I don't want to move my screen yet. I see a few people still peering at what I currently have. All right, I'm going to move this then. All right, so we got to kind of get jumped in real quick here. Anybody give me the vertex for this one? Jacob, what do you got?
-3 and 2.
Good, and how'd you know that, Jacob?
Because Above it and below it, they're both, the Y value is both 5.
Good. And then if we go,
The next one's 14.
Yep. Good. And then 2 above, 2 below, they're both 14. So that means that negative 3, 2 has to be our inside. So we don't know A yet. Since this is a negative 3 in the table, we would hopefully put this as x plus 3 squared. And since our y coordinate is a positive 2, that's the number that gets added on at the backside. Okay. And then now you have a bunch of points to pick. You could pick any of these 5 points and plug them in. I would just pick the smaller numbers just to make your work a little bit easier. So I'm going to pick this point right here. I'm going to pick 4, negative 5 to plug in. So when we now come up here, instead of this y value, I'm going to let my y value be 5 equals A. And then when we get to this x coordinate, the x coordinate in that point was a negative 4. And then same process we did in the previous one. Just go through there solving for A. So should get a negative 1 squared plus a 2. Negative 1 squared is a 1. So it's just 1 times A. Subtract your 2 over. And then A ends up being a 3. So we go back to our equation. And we now know the number in front should have been a 3. All right. Okay. With that, actually the bell would have rang already. We just don't have the bell, so I went a little bit over there. Look this over. You know, if you have any questions, hop on before school tomorrow during the little intervention period if there's anything you need clarification on. But we'll definitely be taking our quiz on all of this tomorrow, okay? Okay, head on off, get to 4th period, and have a good day. All right, see you guys.
Bye, thank you.
Yep, thank you, Alexis.